What's up, guys? Did some mods to this fuel pump driver idea. Ended up adding a second microcontroller to measure the pulse width of the 78 hertz signal coming out of the MegaSquirt box. So the idea is I'm now measuring the pulse width, or the on time, and converting that into a value that gets shoved into the digital to analog converter out of a Teensy3.2. So that analog out is now getting fed into the analog in on the DC motor controller, which I'll show you here in a second. Alright, so let's see if I get this thing to focus. Alright, so there's the G2 18V25, I think is what it's called. So now the yellow wire is like the analog in, which comes out of this Teensy3.2 board, which is the analog out, and this orange wire comes over to the 12-volt V in from the board, and the white wire goes over to my signal, the blue, coming back from the front of the car, which is bundled up in that gray wire there. So all that's still the same. So now we're able to measure the PWM in, and then I'm just stealing 3.3 volts and a ground and all that off of the DC motor controller. So that's how it all kind of combines together now. So it's actually working pretty good, the PID loop. So the PID loop tuning is working a lot better now. It's a lot of more linear and snappier, where before with the low pass it was pretty lethargic and wasn't quite getting to the target value, or it would overshoot really bad and was having a hard time maintaining the target when you got the motor up into high load or any type of quick fuel load changes. As the duty cycle would ramp up, the fuel demand would also need to ramp up pretty quick. So I was having issues with that, maintaining pressure under higher engine loads and any type of big throttle change. So I'm going to show you real quick on the laptop what all this looks like. Let's see if I can do this. Alright. So, fuel pressure stuff. So the way I have it set up now is we're still 78 hertz, the polarity on normal, 34 rail pressure. So I still set a minimum duty of 5%, maximum duty of 95%, because you still need a pulse train coming in for it to measure. So you kind of need to set up a min and max, so you don't go to zero and you don't go to wide open. But that's so far that's what I got. PID numbers are now a little bit more manageable than what they were before. They're pretty crazy before, and result in some really weird behavior. But this seems to be working pretty good. So we'll do a engine start here in a second. Alright, so that kind of concludes, I think, how far I'm going to go with this specific DC motor controller. Driving the fuel pump, it's working. It's really quiet. It's running at like 22.5 kilohertz. I think with what I've learned, I might try building a speed controller using that Teensy3.2. What's nice with that 3.2 board is it has a CAN bus output. So you just hook a CAN transceiver up to it, and then I can packetize data. I can say like system voltage, current, DC motor speed, percentage between 0 and 100. I can kind of put out some useless data that you might only want to look at once, but it'll be kind of neat to have. I could spit it out over the CAN bus and receive it into the MegaSquirt box and do some math on it and whatnot. So that's an option. It's I think it's pretty easy just to do a low side driver. There's a bunch of ICs I found out there, integrated components that will do like a MOSFETs and stuff that will do a 3.3 volt in on the gate and allow you to do a PWM motor at like 22 or 20K, 22K. The Teensy has timers that will do a 10-bit PWM resolution at 23 kilohertz, which is so I might just set it at like 22K, set the timers up to do a 22K PWM, and then drive an in-channel MOSFET that's capable of say like 50 amps or something with like a 60 volt flyback or protection and all that stuff, and we'll throw a diode across the circuit anyways. But I might build something that gives me a little more flexibility and whatnot, so we'll see. It's just a car. Bye.